Good morning, good morning. I'm GLM, and today I want to show you how you can send programmatic transactions on the Conflux Network with Python. This GitHub repository is called conflux-rpc-send-python, and it is a collection of a few Python scripts that allow you to do exactly that. We will cover sending CFX to a different address, both on core space and eSpace. We'll cover swapping via swappy.io, decentralized exchange, as well as something unique to Conflux Network, is sending CFX through the cross-space bridge. That's what this script does. Let's quickly go over the README. So, again, these are Python scripts. They have some requirements. web.py is the standard library for interacting with EVM blockchains in Python, similar to web3.js. And Conflux Web3, what is this? This is a fork of web3.py, also called python-conflux-sdk. It's basically web3.py, but explicitly for use with Conflux core space. Covered what our scripts do already. Shared features, so batching, these scripts have the ability to spend multiple transactions at once. I'll cover the different strategies to do so. Report, this just outputs transaction information so you can trace it on scan. Private key management. This is important. So we will have two private keys that we'll use during this example, one for core space and one for eSpace. We will input them into our shell as environment variables. I will be careful not to share mine, and you should be absolutely careful to never ever share yours. So let's dig in. Alright, so let's clone this repository as if I've never seen it before, just to give you the full example of how you can use this. On GitHub, at the top, press code, copy this URL, git. So I'm cloning it via git bash. You can also just download these. So in here, I'm going to go to the folder where I keep stuff. And I'm going to say git clone, insert that URL. It's going to pull the repository down locally. And let's see what happened. Okay, cool. So we've got our scripts here. Let's go ahead and open that up in Sublime so you can see. We're going to get started with eSpace swap. And I'm going to execute these in Anaconda. Again, there's a million different ways to run Python. I'm on a Windows machine and I'm using Anaconda. And my Python version is 3.9.7. For this use case, really, I think Python 3.7 through 3.12 should all work the same. Okay, so we've got our repository pulled locally. We've got our Anaconda prompt up. That's where we're going to execute our Python. First thing we want to do is install the requirements. So what I need to do is change a directory to where this is installed. Under conflux-rpc-send-python. Now I can install the requirements. So I already have them. So it's just going to be a bunch of requirements satisfied. But this is where, if you don't have Web3 or Conflux Web3, it'll install them. Cool. Right. Round trip. So going back to our README, we're going to set up private keys. So, and again, I'm on Windows, so I'm going to copy this here. So I'm within my shell. This is my environment. I can set variables here. I'm going to set these, both of these, off screen so you don't see them. And remember, never share your private keys. What I'm doing is I'm just copying them without quotes because I have my private keys here. Where do you get private keys from? Usually if you just go into your wallet, there will be an option to kind of view private key, and you export it from there and then just put it into, in this case, our Python environment. Okay, so all I've done off screen is set these two to my private key and then cleared the screen. What do we want to do? So let's take a look at eSpace-send. I already have that up here. Let's go ahead and execute it. Python eSpace-send.py. Oh, I'm not in the right folder. cd conflux-rpc-send. Now eSpace-send. It's doing stuff. This is the little report. It says it packed 2 transactions. Started to send them at this time. Sent 2 transactions. From and to. The from and to are the same in this case because it's just using the default in the script. Gives you the gas estimate and the last nonce hash. This is probably the most important thing. Last nonce number, and this is the transaction receipt. So this part is async. If I send a bunch of transactions, it might take some more time to get this receipt. But again, let's copy this hash, go to evm.conflux-scan.io, put that in the search bar, and we'll find it. Cool. So, yeah, sent, from, to are the same, and it's sent 6-way. Now this is sort of 6 of the smallest number of CFX that can be sent. What is way? Let's go over that quickly. In blockchain parlance or EVM parlance, it's, an ether is, we even still use that word, ether. It just means like 1 ether or 1 CFX for us. A gwei is whatever this is, amount of CFX, and a way is the smallest amount that can be sent. So we sent 6-way to ourselves. One thing to know is the library we're using expects an integer input. So that's why the library also provides this 2-way. So you can say, like, for example, you can say 1 CFX. You can't just put that into the value here. 1 is seen as 1-way. If you wanted to send 1 CFX, you could say, Web3 2-way 1 ether, and it'll basically give you this integer, which would be the same as putting this value here. It's basically, 1-way, you multiply by 10 to the 18th, because there's 18 zeros. And the 1. Okay. So let's back that out. That was way. Let's go over the code a little bit expand this up. What is this doing? Now I'm going to go over, there's boilerplate in these scripts, I'm going to go over it once. We import some Python libraries, including web3.py. We set up our provider RPC. This one is hard-coded to use EVM mainnet. So this is eSpace mainnet. There are, for both mainnets, there are like a US endpoint and a Hong Kong endpoint. So you can use whichever one is closer to you, as well as the testnet endpoints are provided for both eSpace and core. So after that, we set up our Web3 provider. This is just how these libraries work. Wallet config, we've already set up our private key, so we don't have to do anything here. As a backup, you can put your private key here, but don't do that. This part just decides which of the environment variables to use, and it just keys off of the presence of EVM. So if EVM is in the RPC name, then we're going to want to use the EVM private key. Account from, this just takes our private key, gets it from the environment, asserts that it is present, and this web3 eth.account from key basically sets up your account will have the private key as well as the address. And here we get the start nonce. So you know, all transactions have to have a nonce. It's basically like the number that this wallet has sent. So you start from 0, I believe, and you go up. We are, for this particular wallet, I don't know if you can actually view it here, but it'll be in our report. It's quite high because I've used this wallet for a lot of testing. We can include a little message if we want. By default it does. You can just write a string here and it transforms it to hex and includes it in our transaction. So that's how we put Conflux forever here. But you can change it to whatever you want, or you can remove it if you want to save just a bit of gas in your transactions. So these scripts have this, they all share the same framework where it basically sets up defaults, and all this is derived from the data it already has. So the complex chain ID, the start nonce, gas price. This will kind of query for the current gas price. From is us, values set to 0 here, and we include that bit of data. Next thing it does is it estimates. So it will take these inputs and estimate how much gas it will cost to execute that transaction. We do this up here because we do the estimation once, and potentially later on we might use that same estimate to send many transactions. So this updates the defaults gas with the estimate result. Now, inside the main body of the script, we have this kind of choice here. Now all these scripts are going to have this repeat one variable, and repeat one's really for like testing or experimentation. By default it's false, and by default you will enter this block, and this is basically manual input. So it will execute, this says there's 2 transactions I want to execute. The first one is with this value and with this to address. So if you just want to send one, take a row out, save it, and resend. As you can see, sent 1 transactions. This is also helpful if you have an airdrop or something that you want to execute and you just need to specify, you know, X amount of addresses and amounts that you want to send, you just edit this manually. What happens here is remember earlier we set up our transaction defaults. It takes that default, again, this is strictly because we're trying to do this multiple times. It takes that default data, copies it, and then updates it with the values from our values matrix, which is our specifics for each transaction. Updates them with the specifics, kind of signs all of them, and then puts them into a cache. It doesn't actually send them yet. Once they are all signed and packed, it will send all of them down here. Now, going back to our repeat one. So if I set this to true, see an example of that, it's going to enter this block, and instead of manual input, what you're going to do is you say, okay, I want to send 20 transactions. I want to send 4-way in each transaction, and they're all going to go to this same address. And what these two blocks do is they both create this values matrix with the same schema. So let's save this and see what it looks like. Now it's sent 20 transactions in about half a second. Cool. If I copy this block hash or transaction hash, see it's still pending. Now it's executed. So conflux forever, and it's sent 0.4. So that's how you can use the different, the two different approaches within each script. Send this back to false, just because that is the default. And let's move along to eSpace swap. So what is this going to do? This is going to swap one CFX for whichever token we have specified in the script. This little bit, you can see, it has some of the same boilerplate, but now we're introducing a contract. And so this contract is the swappy router. It has an ABI for that. An ABI is sort of a schema that enumerates all the things that the contract can do. And we save that contract. We give it the WCFX address. You will only need CFX to execute this, but similar to like Ethereum and all the other EVM chains, the liquidity pairs on Swappy are going to be WCFX and whichever ERC20 token the pair is set up. And the CFX to WCFX is sort of done implicitly, so you don't need to know anything other than this is the WCFX address, and this is the address of the token we want to swap CFX for. Now if I look this up, what is it? It's Confidoge. Confidoge is just a meme coin set up by the community, the Conflux community, and it's a fun thing. I'm happy to spend a few CFX to support them. The amount that we're going to send is, here's that 2-way again. We're going to send 1 ether, which means 1 CFX. The specific inputs for this is the contract function we're going to use, swap exact ETH for tokens. It requires sort of a bypath. Say I want to go from this to this. I specify the amount of slippage I'm willing to tolerate. And here's where it calculates. It actually calls the contract function. Again, a contract function call does not cost any gas. It calls this function. It says, hey, how much of this token will I get for 1 CFX. And we save that, and then we say, okay, our minimum that we'll accept back is that value, basically times 1 minus the slippage. We set up our transactions params directly here. We give it a good amount of gas. It will not use all that gas. It will use just as much as it needs with the inputs we've calculated. And then in this case, instead of sending a transaction, we're calling this contract function directly with the inputs we calculated. We build that transaction, save it locally. Now, this is a little bit different. We're estimating afterwards because we need all of these inputs to do the estimation. Again, we update the gas with the estimate result, sign it, and then we execute it. So let's do this. Did we already execute this? No, we did not. So this is eSpace swap. eSpace swap.py. Oh, already gave us a hash. Let's look the hash up. It is not found yet. Now it is found. And there's our transaction receipt. This one's going to be significantly bigger because these transactions emit logs, and within those logs there's a bunch of data that you could read if you are so inclined. You can also see that data here. So we're not going to get into that today. So token transferred 1 WCFX for 21,000 Confi Doge. Cool. And then if I execute it again, should be, I imagine it might be a slightly lower value, again, because this swap will have affected the liquidity curve slightly. So if we go from 21.117.2 to 21.117.2, let's see, 58.19. That's actually hasn't really affected much at all. Yeah, but if we were swapping more CFX, we would actually be affecting the liquidity curve, and that is also why this is the only script in the package that only executes a single transaction. This doesn't really make sense to queue up a bunch of swaps where we could be affecting the required inputs. So that's eSpace swap. Let's bring this back down to size. Put that there. Let's take a look at the core space scripts. So core send.py. Let's execute that. Gave it some nonce hash. And for this, instead of looking at EVM.conflux-scan, we're just going to look at conflux-scan. And excellent. We executed, we sent our little 6-way to ourselves. Cool. So again, I already went over everything that's basically in here. The only difference between eSpace send and core send is going to be we're importing Web3 from that Conflux Web3, which is the forked version developed by Conflux. So there might be some very small differences in how these execute, but generally it's going to be the same. We introduced something for core called storage limit. Excuse me one sec. My apologies, I am sick. So I sound like this. This is unique to Conflux Core. We won't have any storage involved in this transaction, but it's something I've provided here so you can see the difference. You can see these on chain, if I can spell storage right. Yeah, so these are all 0 because we're not actually storing any data in this transaction. But if we were, we'd have values here, and we'd have to estimate the right amount of gas that we would be paying to store that data. And then the way Conflux Core works is if that data was changed or deleted in the future, we would actually get that storage collateral back, and some of it would be burned. That's a whole nother topic, but I figured I'd mention. Same repeat one framework, same defaults. This is all going to be otherwise exactly the same. So let's move on to core transfer EVM. What does this guy do? This guy is going to EVM.py. It's going to use the cross-space bridge, namely the contract that is the core space bridge. It's going to send CFX to this contract with a to parameter of an EVM address. So what even is any of this? Okay, let's look it up here. So conflux scan, look up the hash. So what is this? It is a contract interaction. We are saying transfer EVM some CFX to this EVM address. This is kind of unique in that this is the only place where you'll see like core space parlance and addresses, as well as eSpace parlance and addresses commingled. Did this use any storage? I'm not sure. It did not. But there's two ways that we can see this on both sides. So I should explain both sides. Conflux is divided into core space VM and eSpace VM. And this is the method in which you can take assets from one side of the ledger, in this case CFX, and put it on the other side of the ledger. So if I go to EVM and I look up that address, the same one we've been using, I got 2 transactions because we're still doing 2 in all these scripts by default. Let's look at the last one. We sent our 6-way. It says it came from this weird address. That is sort of the plumbing involved in the cross-chain transaction, or cross-space transaction. It can also be helpful if we look at this. It says epoch, but this is the block number. If we look this up on eSpace, it should be the same. 408, 408, but let's do it this way. And you can see this is the block as viewed from both sides of the ledger. If we look at the eSpace side, transactions, there's 4 transactions because we did it twice, basically for each of these cross-space calls. There's going to be a transaction triggered by the 0 address to an interim address with our amount, and then that interim address is going to then send to our address. So this is how you can trace, specifically if you're on the eSpace side. If you're on the core space side, it's easy to kind of see the destination here. But from the eSpace side, you can go through the block to see what the originator of this transaction was. So it's a little bit esoteric, but there's a lot of interesting learning that could be done if you want to dig further into cross-based transactions. That's probably it for now. We covered all 4 of our scripts. We executed them. I showed, explained way, as well as explained our little repeat one framework. Explained kind of the strategy within the scripts is to set up defaults, estimate with those defaults, and then kind of polyfill these specifics for each transaction, pack all those into just a local cache, and then send all of those transactions at once. Something I want to show you might be interesting. That's basically all I've covered everything I wanted to talk to. I just wanted to show you something interesting. So if I go to eSpace swap and I say, where is it? No, eSpace send, sorry. Let's do some repeat one. Let's say I want to send 1,000 transactions. Space send. Let's go. This might take some time because again, it's packing all of those transactions locally before it sends them. Packed 1,000, starting to send. Now this may take some time. So the throughput of eSpace is about 1/5 of the throughput of Conflux Scan, or sorry, of CoreSpace. So we said we can send all these transactions in 22 seconds, but it's going to take some time because we are awaiting the last nonce. If we see if it's registering. Okay, it's executing a lot of those, but it's taking some time. We sent 1,000 transactions to the RPC, which means they all went into the transaction pool, and it's packing as many as it can into each block, and it's using the gas to all of ours are going to be sent with the same amount of gas, so it doesn't really matter. But sometime within the next minute, all 1,000 should be executed. And there's our receipt. So you can do a little calculation that says, okay, we sent all 1,000, 22 seconds, and we started at 9:27:05. This one executed at 9:29:13. Okay, so it took about 2 minutes for all 1,000 transactions to be kind of packed and executed on eSpace. Do the same thing on core. Say repeat 1, true, batch size 1,000. These are all going to be exactly the same, except for same as what we did on eSpace, except for they're not going to include a little bit of data, a little bit of message we said, but it really is a small difference. So if we say core send 1,000 true, save it, Python core send py. Let's do the same thing with CoreSpace. Okay, back to 1,000, starting to send. Let's see. this transaction. Okay, it's doing its thing. And what we're going to do is see the execution time difference. It should be about 5 times faster, just because there's only 1/5 of the blocks. Oh my, it's already done. So let's take a look at this. And again, this is the last hash. So of the 1,000 we packed, this is number 1,000. So now we started sending transactions at 9:30:36, and this executed at 9:31:05, so 30 seconds. So what took 2 minutes on eSpace took 30 seconds on CoreSpace. Which is about right, because CoreSpace just has access to all of the blocks, while eSpace only has access to about every 5th block to pack all those transactions. So just a little fun experiment, but also to show you kind of that's why the main reason why this repeat one framework. Do some experimentation and kind of learn more about the blockchain. I enjoy doing this, especially with Conflux, because it's cheap, it's fast, and it's really helping me learn core tenets of blockchain. So thanks for staying if you're still here. This again, github.com, conflux-rpc-send-python. I hope we covered everything. I've been GLM, and thank you. Enjoy Conflux and learn some EVM. See you again soon.